Alright, what's up guys? In this video we're going to pick up with some calculus here. We're going to do another integration practice video. So we got a definite integral from 1 to 2e. We got 3 raised to the natural logarithm of x, all divided by x dx. Okay, so this one's pretty easy. I would just start with a u substitution. If we let u equal the natural logarithm of x, taking the derivative of that, we know just gives us 1 over x. We need to multiply by dx. We also need to solve for dx. So we'll do that. We'll get x du is equal to dx. So what's going to be happening is the x's will end up canceling. So I will no longer have an x down here. And I know I'm going to have to change the limits. So I'll leave the bounds blank. And what I'll have is the integral 3 raised to the u du. Now we can go ahead and change the limits. So remember, since u was equal to the natural logarithm of x, all we have to do is just substitute in a 1 for x and a 2e. So we'll have the natural logarithm of 1. Remember, the natural logarithm of 1 is 0. And then I'll just have ln of 2e, which doesn't simplify out to anything. So now the new limits are going to be from 0 to the natural logarithm of 2e. And we'll have 3 raised to the u du. And remember, if I have an integral b raised to the x dx, for example, that's just going to be b raised to the x, all divided by the natural logarithm of b plus c, if it were an indefinite integral. And remember, there's an important restriction on this formula. Remember that b cannot equal 1 because the natural logarithm of 1 is 0, as we saw here. So if we let if we let b equal 1, well, then we'll have division by 0, which is undefined. So that's an important restriction to remember. The power rule actually has a very similar restriction as well that students forget about. So if I have x raised to the n dx, for example, remember that's x raised to the n plus 1 over n plus 1 plus c, but there's a restriction on this formula as well, where n cannot equal -1, because that'll also give us division by 0. So you want to make sure that you're keeping in mind the restrictions on these formulas, because that'll mess you up from time to time if you're not careful. So we won't go down too far, but if we go ahead and integrate, we'll end up with 3 raised to the u, all divided by the natural logarithm of 3, and this is going to be evaluated from 0 to the natural logarithm of 2e. And I guess I'll go down here. So I'll have 3 raised to the u, all divided by the natural logarithm of 3, from 0 to the natural logarithm of 2e. Okay, so the fundamental theorem of calculus, part 2 that is, says the upper limit gets subbed in first. So we sub in the upper limit first. We'll have 3 raised to the natural logarithm of 2e, all divided by the natural logarithm of 3. We'll subtract that away. We'll stick in a 0. Remember that 3 raised to the 0 is just 1. So we'll end up with minus 1 over the natural logarithm of 3. And since they both have a common denominator in the natural logarithm of 3, we could just end up writing this as 3 raised to the natural logarithm of 2e minus 1, all divided by the natural logarithm of 3, which actually be the answer. So your final answer for this integral we're asked to integrate the integral from 1 to 2e, and it was 3 raised to the natural logarithm of x divided by x dx. So the answer to this will just end up being 3 raised to the natural logarithm of 2e minus 1, all divided by the natural logarithm of 3. And that's your answer. So let me circle that for you. And that's how you evaluate it. So if you guys got any questions about how I arrived at my answer here, please let me know. I'll be more than happy to explain further. But that's your answer, and I'll see you guys next time.